Assalamualaikum warahmatullahi wabarakatuh and good day. How are you? Hopefully you are in very good condition. And as we know, since we are facing the situation of COVID-19 issues, so we cannot relying more on conventional method of teaching and learning. And because of that, I choose to make a special video for you so that the learning process can be continued as usual. We are basically in the still in the topic of confidence interval estimation. Last week we have learned how to calculate the confidence interval for the population mean when the standard deviation of population is known. So we have settled on that. Today we are in the second part where when we do not know the standard deviation of the population, how we are going to do about that. Okay, so this video basically to discuss the basic step of finding the confidence interval for the population mean when the standard deviation of population is unknown. Okay, so last week we are using Z table in order to find the probability. So we can use that table, Z table, when the standard deviation of population is known. But this week, okay, we have the scenario where we do not know the standard deviation of the population. So we are not going to use Z table, but we will use T table instead. The T table. Okay, the formula basically is about the same. We just, instead of standard deviation population, we are going to use standard deviation of sample with the sign of S. Okay, and we to find the critical value or the probability, we are not using the Z table, we will use the T table. And using this table, we have to determine the degree of freedom, which is n minus 1. Okay, now I'm going to show you how to calculate the confidence interval for mean when this population standard deviation is unknown. Okay, but before we proceed for the calculation, let's aware on the first assumption, which is number one is the population is normally distributed, and if the population is not normal, we have to use the last sample. And because of the standard deviation of population is unknown, we have to use the T distribution, not the Z distribution. Okay, so let's use this example to see how we calculate the confidence interval for mean. Okay, let's see in one hospital. Okay, previously they have calculated the mean turnaround time for stress test is around 68 hours previous. And then they think that they can improve the situation, so they have initiated a project. They call it quality improvement projects. After a certain period of time, the project completed, and the project objective is to reduce the turnaround time. So once completed, they take a sample of 50 observation, and from this sample 50, they calculate the mean sample, which is the mean is 32 hours, and also at the same time they calculate the sample standard deviation, which is 9 hours. So from this information, we want to calculate the 95% confidence interval for population turnaround time. So how to do it? Let's see. Okay, first of all, okay, let's see the basic formula first. In the formula, the X bar plus minus is the T distribution. We are going to find the critical value using this alpha by 2. Okay, S square root of n. So we have this information basically. Now x bar is 32 plus minus the t value we will find later, okay, s 9 is square root of n 50. Now to find the critical value for t, we have to find the alpha value here. Okay, alpha here basically, okay, alpha is basically 1 minus confidence level. Here in our example, 1 minus the confidence level is 95%, meaning that 0.95. So alpha basically 0.05. Okay, alpha is 0.05. So once we know the alpha value, we have to see the t table. Okay, so let's say this is the t table. Okay, in t table, look at the table here. We have one column on your left. We call it df, which is degree of freedom. The formula for degree of freedom is n minus 1. Okay, so here up here is basically the area for alpha 1 tail. They call 1 tail alpha. So 1 tail means 1. Okay, here for 1 tail alpha, because this is the picture for the alpha table. Okay, the distribution. Okay, here is basically the area for alpha divided by 2. Okay, so meaning that all the area here is basically refer to this area, alpha divided by 2. So here we know that alpha is 0.05, so here should be alpha divided by 2, 0.05 divided by 2, meaning that 0.025. Okay, so we will look the intersection here. Okay, with the alpha of 0.025, this is basically alpha divided by 2. Degree of freedom n is 50. 50 minus 1 basically 49. 1. We look down here, 49. 50 minus 1. Okay. So see the intersection. So this is the value. Okay. The value for t. So here we can find t is basically 2.0096. Okay, 2.0096. So we put this value into this. Now basically it's 32 plus minus 2.0096. Okay, so the confidence interval, okay, will be the lower limit. Basically, you calculate this, it will be 29.44 up to the lower limit, basically 34.56. Okay, so this is the final answers. Okay, so we how to interpret this. Okay, basically we are 95% okay confident that the interval, okay, sorry, the turnaround time, okay, will be between 24.44 hours to 34.56 hours. So I repeat, okay, we are, okay, basically 95% confident that the turnaround time will be between 29.44 to 34.56. Okay, so hopefully you can follow this. Not that difficult, it's very simple and straightforward. So you can do some exercise in your textbook. If you have problem, then please do not hesitate to contact me. Thank you very much.